Hello geometry students, this is Mrs. Bigelow. We are in section 8.5 and we are still proving triangles are similar. Page 488, please turn your books over to that page. And we are introduced to two theorems, the side-side-side similarity theorem. That'll sound kind of familiar to you if you remember that we did the side-side-side congruence theorem in the fall. Again, you should be able to tell me at this point what the difference between two triangles being similar and the difference between that and two triangles being congruent. In two triangles being congruent, all their corresponding sides are congruent. In being similar, their angles are all congruent, but their sides are proportional. So if you look at my two triangles, A, B, C, and D, E, F, the proportionality, if the corresponding sides of two triangles are proportional, then the triangles are similar. So this is what this is saying. If the length of line segment AB over the length of line segment DE is equal to the length of line segment BC over EF and FD, the length of line segment FD over the length of line segment CE. If that is true, if those three ratios are equal to each other, then we can say the two triangles are similar. Alright, that's the first theorem. Second one is your SAS, similarity theorem. See, I did it just now. Alright, so the side angle side says, oh, I have a typo there. If an angle, let me delete something real here, isn't kind of cool. There we go. Right there in front of you. Okay, so if an angle of one triangle is congruent to the angle of the second triangle, and the lengths of the sides, including those angles, are proportional, then the angles are similar. So, let's just say that angles X and M are congruent. Alright, so the lines that are including those angles would be XZ and XY. So this lines on each side of that angle, and on this triangle MP and MN. So what this theorem says is if angle X is congruent to angle M and XC, proportion of line segment, the length of line segment XC over the length of line segment PM equal to XY over MN, length of line segment XY over the length of line segment MN, then the triangles are again similar. Squiggly line and NP. Alright, so keep in mind that that angle has to be between the two proportional sides. Alright, so I want to give you an example. I'm going to give you three triangles here. I'm going to kind of get a little fun with my colors here. And if you want to browse at the example at the top of page 489, you can see what I'm doing. Alright, so 9, 6, and 10 are the green. Let's go to the blue. Blue lengths are 12, 8, and 14. Oops. It didn't change. Okay. Blue. 12, 8, and 14. And let me put down the reds. The reds are 6, 4, and 6. We're going to look at these three triangles, and we want to figure out, are they similar? So let's take the first two. So I'm going to take the proportion of the sides of these two triangles. So I'm going to go 4 over 6. Is 4 over 6 equal to 9 over 18? Is that equal to oops, where did I get those two numbers? 2 or 3. Is 4 over 6 equal to 6 over 9? Is that equal to 4 over 6? So you reduce these three, you are going to get, looks like you're going to get 2/3 equals 2/3 equals 2/3, which means that basically by the side proportionality, similarity theorem, these two triangles are similar to each other, right? So let's try these two. These two right there. Alright, so we're going to have 4 over 6. Is that equal to 8 over 14? Is that equal to 6 over 10? If we reduce these, we're going to have a 2/3. And it looks like the green probably, no, that's going to be 3/5. And the blue is going to be 4/7. So these two triangles, they are not similar. Alright? What about the first and the last? Just by looking at the green, let's say I say 9, okay, we're looking at the first and the last triangles, 9 over 10, is that equal to 6 over 6? It doesn't look like it. So honestly, guys, it looks like out of these three triangles, the only ones that are similar are the first two. Alright? Okay, so we have a triangle here in example 2, and we want to prove that triangle RST, which is the big triangle, is similar to PSQ. Alright, so do we have enough information on this one? This one, alright, so let's set this up. Is SR, let's go back to the blue. Alright, is SR over SP is that equal to ST over SQ? Okay, so look at those. What's the length of line segment SR? It's going to be 16, right? SP, just 4. ST, 20. SQ is 5. If you reduce those, you definitely get over 4 over 1 equal 4 over 1. So you know this is definitely true right here, that these sides are proportional. Now, to use the SAS, we're going to have to show that the angle between this side and this side and this side and this side are congruent. Well, you obviously see that angle S is congruent to angle S. So by the S similarity theorem, we can definitely say that these two triangles are similar. Alright? Alright, so I'm going to give you homework, and actually when you listen to this, you're going to come in and you're going to have a sub tomorrow. So work diligently, make me proud, and then I will see you guys on Wednesday. So homework